today, I thought what we could do today is we could do some circle analytical geometry, because that's not something that I have done with this class before. So just a reminder about when it comes to analytical geometry. Okay, so this is after it's paper 2. After we have answered our questions on statistics, we would then go and attempt our analytical geometry before moving on to trig. And you can expect 2 questions on analytical geometry. The first question is going to be on your grade 11 work, and that will cover gradient, distance, equation of a line, angle of inclination, sort of various applications to do with that. And then the second question will be on circles. So here you'll still have to answer questions on equation of a line and gradient and angles and that kind of thing, but obviously it all relates to circles. So if you recall, when circles are not centered at the origin, because of course that is our focus in the trick, we use the formula x minus a squared plus y minus b squared equals r squared to define a circle. And if we take a and b and we change their signs, then that gives us the coordinates at the center of the circle. Okay, when they give it to us in this form, it is referred to as center radius form, because it helps us, or we can, from the way in which it's written, read the coordinates at the center, and we can also determine the length of the radius. The other thing that they can do if they want to is they can give it to us in the form ax squared plus bx plus cy squared plus dy plus e equals 0. So they can give it to us like this as well. This is what we refer to. Oh, someone's written something in there. I hope so. I hope so. Is it Jediah? Jediah? I hope I said that correctly. Okay, so yeah, I hope so too. I hope that this will also give you some idea of where you went short and what to expect. Okay, so in this form, it's referred to the standard form. And they could give you the equation in standard form and expect you to be able to write it in center radius form. So to go from center radius form to standard form is very easy, because all you have to do is multiply the brackets out. So when you go from this way to this one over here, you just multiply out the brackets. But when you go back the other way, so in other words, from standard form to center radius form, then you have to go through a process of what? What is it called when you do this? Does anybody remember what the process is called to go from standard form back to center radius form? That's it. Okay, we have to complete the square. Okay, so these are some of the things that they might expect us to be able to do. I don't know that we necessarily need to do it in this question, but I can do, there we go. I can do an example of that with you if you would like. I don't know that that's necessarily what they're going to ask us here, but we do need to be able to do that. The other thing that we're also going to need is our formula sheet. So I don't know if you've got one handy. And a pen and a pencil so that you can also write, and a calculator. But yeah, keep your formula sheet close to you as well, because we're obviously going to need to refer to that for distance formula, or maybe the equation of a line, or whatever the case might be. Okay, so let's get started on this question. I'm just going to make it a little bit bigger and rub this out because this is now in the way. They have given us a diagram with the circle center M, and the equation of that circle is x minus 8 squared plus y plus 4 squared equals 45. Okay, so that's got to be the big circle, all right? Its center is at M. The other thing that they told us is that PT is a tangent to the circle at T, and PT is parallel to OM. Another circle having center O touches the circle at M at N. Okay, so N is the point of tangency between the two circles, and the smaller circle is centered at the origin. Now, something else that I read before we jump into the questions is that they've told us here that PT is a tangent to the circle. So if they tell us that a line is a tangent to a circle, what does that mean for us? What information can we take out of that? Why would they tell us that PT is a tangent to the circle? What does it mean for us? Which line is perpendicular, Amal? You need to be specific here. What is perpendicular? Okay, so MT is perpendicular to TP. Absolutely. All right, good job, everybody. So in other words, over here, we have a right angle. Okay, so very good, very important for us. Okay, let's move on and see what the questions involve. So the first thing that they want us to do is write down the coordinates of M. Okay, so they want us to write down the coordinates of M. All right, so anybody able to tell me what the coordinates of M are? What do you guys think? What are the coordinates at M matrix? Okay, there we go, a whole bunch of answers coming up. Absolutely. Okay, so all of us have got the right numbers, but some of us don't have the correct signs. So remember, we need to change the signs. M is the point in the fourth quadrant, okay, where X is positive and Y is negative. Okay, so the coordinates at M have to be, so we're going to change the sign of the 8, well, -8 to +8, and we're going to change the sign of the +4 to -4. Alondwe, I see you've got your hand up. Do you want to ask a question or say something? You're welcome to unmute your mic and go for it. Alondwe, I don't know if you wanted to ask a question or if it was just a mistake.
Mistake.
Say again.
Mistake.
Oh, mistake. Okay. All right. No problem. Okay. The next thing that they are asking us for here is calculating the length of OM. Leave your answer in simplest surd form. So they want the length of OM. Can you guys do that by yourselves? Can I leave you to do that one, and you can share your answer on the chat with us? When you've got an answer, you could pop it into the chat, and then I'll explain where the 2 marks were for. So calculating the length of OM. Okay, so Emihle has shared an answer. Thank you for your answer, Emihle. So has Amal. Thank you, Amal. Okay, so question 5.2 is not meant to be a difficult question at all. It's meant to be straightforward. It's supposed to be one of those things that we all get right. So yeah, thank you for sharing, Nalwazi, Naledi, Timna, Amal, and Emihle. All of you are correct. Okay, good job. All right, so you would have subbed into distance formula and you would have said 0 minus 8 squared plus 0 plus 4 squared, and that would have given you the 4 root 5. Okay, so very important in maths when we use a formula, we've got to show that we've subbed in, and then we're going to show what our answer is as well. Obviously, we would get a mark for the coordinates at the center. Now they want us to calculate the length of ON. ON. How are we going to do that? The length of ON. Okay, so that's just this bit over here, matrix, just from there to there. So we've already got the length of OM, right? So how are we going to work out how long ON is? What do you think? Okay, but Amal, I want to just hang on a second. Okay, so you're saying midpoint, Ntokozo and Amal. The midpoint of what and why the midpoint? Are you talking about the midpoint of OM? Okay, but if you find the coordinates at so when you say the midpoint of ON, are you talking about finding the coordinates at the midpoint? So in other words, over here. Absolutely, Ibrahim. Okay, ON is a radius. It is the radius of the smaller circle, quite right. And do we know anything about the equation of the smaller circle? Let's go back up here and go and have a look. They told us anything about that smaller circle other than the fact that it's centered at the origin. Do we know anything about it? No, we don't, do we? Okay, so we know that ON is a radius. We also know that NM is a radius. Just saying. So how is knowing that ON is a radius and NM is a radius, how is that going to help us? N cannot be the midpoint of OM because the circles are not the same size. So therefore their radii cannot be equal. So ON definitely does not equal NM. So what do you guys think? How would we work out the length of ON? Remember, you have the equation of the circle, of the bigger circle. I'm going to give you a couple of minutes to think, and then I'll talk about it some more. There's a critical piece of information that they have given you that's going to help you solve. Unfortunately not, Ibrahim, because we don't know the ratio of ON to NM. We don't know that ON is twice the length of NM. They haven't told us that. There's something else in the information that's given that the clue is. Another piece of information that they have given us that we're just not looking at. Okay, and that's this piece of information over here. What have I just highlighted? Yes, quite right, Snegugu. OM is parallel to PT, but that's not going to help us. Just because lines are parallel doesn't mean that their length is going to be the same. Okay, so in other words, what I can do here, Snegugu, is I can draw a line that's this long, and I can draw a line that's long. They're still parallel, They'll never touch, but they're not equal in length. Okay, so this little thing that I have, okay, so don't feel bad. What have I highlighted here in blue, guys? What does this 45 represent? Remember, this is the equation of my circle, right? So what does that 45 represent? What does it mean for us? Ah, okay, so it's the radius squared, isn't it? Okay, because remember, the equation of a circle in this form, in center radius form, x minus a squared plus y minus b squared equals r squared. So when they give you the equation of a circle in this form, the number on the right-hand side is going to be the square root of the radius. Okay, it's going to be the radius squared, sorry. Okay, so in other words, 45 is r squared. So you can see from the diagram that r is nm. That's for the big circle. Okay, so if we know the length of OM and we subtract the length of NM, we can get ON. So in other words, what I'm saying is this, ON is going to be OM minus NM. Look at the picture. ON is going to be OM minus NM. Okay, because we don't have any other information about that little circle. All right, all we know is that it's centered at the origin. We don't know the length of its radius. Okay, so that's why we have to use what we do know. So if r squared is equal to 45, then what is r or nm going to be equal to? Nm is going to be equal to root 45, isn't it? So what we can do here is we can sub into OM. We know that OM is 4 root 5. And from that, we need to subtract the square root of 45. Okay, so let's do that. What do you guys get as an answer? That's it. Okay, 100%. Well done. We are getting root 5 as an answer. Okay, good job. Now, I just want to check in with you. Is everybody okay with that? Does 5.3 make sense to you? So you can give Neliswa and I a thumbs up or a smiley face or a thumbs down. Good, Nolwazi. Good, Alondwe. Okay, is that making sense? Is 5.3 making sense to you? Do you understand why I've worked it out this way? Sure, of course, no problem. Okay, so everybody else who does understand what's going on, just give us a second. I just want to explain this one more time. No problem, Kamogelo. All right. If we look at the information that we have been given, we do not know anything about the equation of the smaller circle. So because we do not have the equation of the smaller circle, we don't know what the length of ON is. All right, all we know about this smaller circle, and I mean, writing this really doesn't help us, is that it's x squared plus y squared equals r squared. That's all we know about the little circle, right? So this is unknown to us as well, all right? So because we don't know anything about the equation of the smaller circle, we can only use the equation of the bigger circle to help us. So when an equation is given to you in center radius form, like this one is, this is center radius form here. The number on the right-hand side represents the radius squared. That's what it means. So in other words, as far as the big circle is concerned, the radius squared is 45 units, which means that the length of the radius is the square root of 45. Now, the radius in this situation can also be called NM. NM is the radius, and it is root 45. So this is a difference problem. In other words, if I know the length of the whole line and I subtract, so in other words, I know all of this, right? If I take the green bit away, I'm left with the yellow bit. That's what's left over. So that's what I was trying to say over here, is that the radius of the smaller circle ON is going to be the line OM minus NM, the radius. Okay, so since I already worked out what OM was over here, I knew that this was a clue for me and that I was going to use it. Because remember, in paper 2, it's all about, I suppose in paper 1 as well, but maths is all about stories. And it's all about, well, what's part of our story already. So if OM is already part of our story, then they probably want us to use that in order to be able to get to the answer. So always go back and look at what you've already calculated and say to yourself, how can this help me? All right, I worked out the length of OM because of what reason? How is this information going to help me answer the next question? All right, especially in paper 2. All right, so we know that OM was 4 root 5. We worked it out in 4.2. And if we take away the radius of the larger circle, aka NM, then the little bit left over is ON. Okay, so that's how we did it. Does that make sense? Oh, good, Ibrahim. I'm glad to see you've got a thumbs up. Good. And Tukoso, I'm glad. Okay, so that's why it's nice for us to have a bit of a smaller. It's a pleasure, Naledi. Good, Kamchelo, I'm so glad. All right, so please do ask. I've got absolutely no problem going back over things lots of times just to help you guys understand. Okay, so that was 5.3. It's out of 3 marks. So here we obviously have to have a mark for our answer. I would say that there has to be a mark for subtracting NM from OM. And then, of course, we had to work out that NM was root 45 because we already had OM from the previous question. Okay, so now that we've done all of that, we're down here at question 5.4. And what they want us to do is they want us to calculate the size of OMT. Okay, so we're going to go back at the diagram. We're going to have a look. OMT is this angle over here. Okay. How are we going to work out the size of this angle, OMT? I'm just going to get rid of that. What do you think? OMT, so the angle in red. Any ideas as to how we're going to calculate the size of OMT? Again, look at the mark allocation. It's for 2 marks. So it can't be something too difficult or too complicated. Again, what's already part of our story? What do we know? Okay. So, Sneh Gugu, you are normally correct. It would normally be angle of inclination, okay? But there is, since there is a tangent, yes, so because there's a tangent, we know that the radius is perpendicular to the tangent, didn't we? You all told me that at the beginning, all right? So that at T, MT meets TP at right angles. So that's already part of our story. How can that help us? What happens when we have parallel lines when it comes to angles? What sort of angles do we get with parallel lines? There we go. What sort of angles do we get with parallel lines? These are our little fun angles from when we were in grade 8, grade 9, grade 10. There we go, alternate angles, quite right. So look here, matrix. Okay, you've got this parallel line over here and that parallel line over there. Okay, and there you go. The angle at T and the angle at M, they are alternate angles. They make a Z shape, okay, between parallel lines. All right, that was really good. Well done. So now we just got to make sure, can you see that intercausal? So now we just got to make sure that we write that down. Okay, so it's important for us to say that angle MTP is 90. And that's because the radius is perpendicular to a tangent. Therefore, NMT is equal to 90. And that is because of alternate angles, because NM, or you could say OM if you want to, is parallel to TP. Now, you must be very careful at matric level, all right? If you use alternate or corresponding angles as a reason, do not forget to name the parallel lines, okay? Because they will not be very forgiving of you in finals if you leave those off, okay? So if you use corresponding or alternate angles to prove angles are equal, you absolutely have to name the parallel lines as well, okay? All right, so intercausal, if you want to do it by angle of inclination, all right, I suppose you could, but then you would have to do constructions, and we shouldn't really be needing to do constructions. But the other thing is, yeah, I'm just thinking about what you said here. Okay, so there would be 1 mark for that, and then there would be 1 mark for that. So intercausal, if we did do a construction here, what we would need is we would need a straight line, right? So now if we've got this straight line over here, just see if I can move it up a little bit. No, it doesn't want to go up. Okay, so you've got that straight line over there, all right? So then what you could do intercausal is you could say that this bit in red over here is the green minus the yellow. Can you work out the gradient of line MT? Well, we know we can work out the gradient of OM because we've got the coordinates at O, we've got the coordinates at M. But we would first need to establish that MT is perpendicular to TP anyway. So yes, I suppose you could do it that way, but it's going to take you a lot longer. Okay, so yeah, I wouldn't do it like that. Not for something that's worth 2 marks. Okay, intercausal. No problem. Okay, not that there's anything wrong with trying to do things in different ways. I think it's wonderful that we think like that, and we must think like that in maths. But if there's a quicker way for us to get to the answer, then we don't necessarily want to do lots and lots of working out, because we're going to need time. I mean, if you look here now, so now we're getting into questions that cost more marks, out of 5, out of 6. So we want a little bit more time on our hands to be able to answer these sorts of questions because they're worth a bit more. All right. So if we can get through something that's 2 marks a bit quicker and easier, then let's try and do that. Okay, so now they want from us the equation of MT. Okay, so the equation of MT. All right, so what does MT represent? MT is what? MT is the radius of the larger circle. Okay, so in other words, they are asking us to find the equation of the radius. So I'm just going to highlight it for us. There it is over there. Okay, and we know that the radius is perpendicular to the tangent, and we also know that that's a 90-degree corner over there because alternate angles are equal. Okay, so now when they ask us to find the equation of a line in the form y equals mx plus c, what do they want from you, Matrix? What's it your job to calculate? What are they expecting you to do? So Amal says we need coordinates and a gradient. Absolutely. Okay, so we need a gradient because, and corso, first the gradient must be calculated, quite right. So the gradient is represented by the letter M. Okay, then we need coordinates, okay, of a line, of a point that the line goes through, so that we've got a corresponding X and Y, so that we're then able to work out what the value of C is. Okay, so quite right. We need the gradient first, and then we need a pair of coordinates. What coordinates do we already have? Do we have coordinates at T? No. Do we have coordinates at M? Yes, absolutely. Okay, so MT goes through M. So we know that the coordinates there are 8 and -4. Remember, that's already part of our story. So that's our X and Y sorted, right? All we need to do now is work out how we're going to get the gradient. How are we going to do that? How are we going to work out the gradient of MT? That's the only bit that's missing before we can solve for C. How are we going to get the gradient of MT? What do you guys think? Okay, but intercausal, if we use the gradient formula, then we need the coordinates at T as well, don't we? Because we need to use gradient formula, we need 2 points. We need y1 and y2 and x1 and x2, don't we? But we don't have the coordinates at T. It's okay. So, Kamgelo, y minus y1 equals m times x minus x1. That's the equation of a straight line, and we're still going to need the gradient. Okay, what does Pilo say? All right, gradient of nm is equal to gradient of, hang on a second, of mt. Are you sure about that? Are you sure the gradient of nm and the gradient of mt are going to be equal? Don't say sorry, Kamgelo. Okay, you guys are trying, and that's the most important thing. Okay. Yes, I agree with you, nm. So if nm and mt are radii, then they must be equal in length. Their gradients are not necessarily the same, though. Okay, because if you think about it, if you were standing at n and you walked to m, you'd be walking downhill, wouldn't you? If you were standing at m and you had to walk to t, you'd be walking on a very steep uphill. So the gradient is not necessarily the same. The length of the line is the same. nm and mt are the same length, but their gradients are not necessarily the same. Mangaliso, okay. Can't we calculate the gradient of OM? Sure we can. And then what are we going to do with that? Mangaliso, once we've got the gradient of OM, what can we do with it? You're getting very close now. All right, Mangalisa made a very nice suggestion there, Matrix. Can we work out the gradient of OM? Yes, we can. How do we use it though? Okay. Oh, Daniel, what have you said? The lines are perpendicular, so if you times them, they equal -1. Okay, if you times what, Daniel? What about the lines? Do you get -1? There we go. Okay. So Daniel's onto something here together with Mangaliso. Some of you are saying that the gradient of OM and the gradient of TP is the same, and that is true. That's absolutely true because OM and TP are parallel to one another. Quite right. Okay, so in other words, if we know the gradient of OM, then we know the gradient of TP. But they're asking us to work out the equation of the radius, right? Now, the radius is not OM or TP, it's MT, isn't it, right? And it is not parallel to OM or TP, it's perpendicular. So what Daniel was saying, all right, is, yeah, look at the relationship between OM and MT, okay? They are what sort of lines? Okay, so OM is perpendicular to MT. Okay, so they meet at right angles. Remember, we've just concluded that in question 5.4. So when lines are, yes, Amal, when lines are perpendicular, what can we say about their gradients? If lines are perpendicular, what does that mean about their gradients? Okay, when we times, that's quite right, Kamogela. When we times them, we get -1. So in other words, if we have the gradient of OM and we multiply that by the gradient of MT, we get -1. Very, very, very important. Okay, the product of their gradients is -1. Beautifully said, Ibrahim. Absolutely beautifully said. So you have to multiply them to get -1, quite right, into causal. Okay, so in other words, we can do what Mangaliso suggested. Mangaliso said, can't we work out the gradient of OM? Yes, we can, because we've got the coordinates at O and we've got the coordinates at M. Then we can say the gradient of OM, whatever it is, times the gradient of MT equals -1, and that'll give us a way of being able to work out the gradient of MT. Okay, so what I'm going to do is, now that we've spoken about it, I want to see if you guys are able to do that. Right, so just see if you can work out the gradient of MT. Remember, because OM is perpendicular to MT, the product of their gradients is -1. So work out the gradient of OM, and then the gradient of OM times the gradient of MT equals -1. Let's see if you guys can do that. Okay, and then when you've got an answer, you can pop it into the chat and we can answer the next part of the question, okay? There we go. Lovely. Well done. You're all getting the right answer. Quite right. So the gradient of OM is minus 1 over 2. And it makes sense because OM has a negative gradient. Okay, remember we said if we were standing at M and we walked to M, we'd be walking downhill. Quite right. Okay, so how are we going to set that out? As follows. All right, this is what we are required to write. We have to write, so in 5.5, we have to work out the gradient of OM using gradient formula. So remember the coordinates, the origin are 0 and 0. So the change in y, so that would be 0 plus 4 over 0 minus 8 gives us minus 1 over 2. Okay, so we've got to do that first. Then once we've got the gradient of OM, we then have to state this bit over here, all right, which is that the gradient of OM times the gradient of MT equals -1. Okay, and that is because NMT equals 90. So now we can sub in our minus 1 over 2 times the gradient of MT equals -1. And sorry, I'm writing it over here, but the gradient of MT would therefore be equal to 2. Is everybody okay with that? Good, and Ntukozo. That's it, quite right. Lovely, Amal. Well done. Good, Liam. Good, Timna. Pleasure. You've done great work. Bonolo, do you want to ask a question? Your hand is up? Or are you just saying thumbs up? If you want to ask a question, you're more than welcome to unmute. Okay. That's good. Well done, guys. All right, so we're almost there. Remember, they wanted the equation of MT in the form y equals mx plus c. So we're almost finished, Matrix, because what we've got so far is this. We have got the equation of MT. We know that it's y equals 2x plus c. Okay, because we've worked out that the gradient is 2. Right, so we would have had to do that as well. So that would give us a mark for that. Now we've got to go and sub in. Remember when we were looking at this problem in the beginning, we were saying that we've got this x and this y because we've got the coordinates at M, which is a point that MT goes through. So now that we've worked out what the gradient is, now it's our job to work out the value of the y-intercept. Okay, so now we're going to have to sub into y equals mx plus c, or if you want to sub into y minus y1 equals m times x minus x1, you're welcome to use that as well. Not a problem. Okay, I think it's just easier to use this. So now we know that y is equal to, there's our y, there's our x. Okay, so now we can come down here and we can sub in our -4. And we can sub in our 8, the coordinates at M, and we can work out the value of C. Okay, so C is going to be equal to -4 minus 16. So that means that C is -20. So that means that the equation of MT, it is the line y equals 2x minus 20. Yes, Amal, I see you've got a hand up. Do you want to ask a question?
I just wanted to know if it's okay if we use the formula y minus y1 is equal to m brackets x minus x1. Will that also be okay for this type of question?
Absolutely, Amal. Absolutely. If you want to use that formula, you're more than welcome. Okay, no problem. Pleasure. Okay, good, Ntukozo. Okay, is this making sense to everybody? How are you guys feeling? Let's just do a quick check-in. Are we all happy with that? Does it make sense to us? Oh, good. Oh, that's lovely to see, guys. I'm so pleased. Well done. Good. Nice. Good job, everyone. Okay, that's lovely. Lovely, lovely, lovely. All right, so now some of you at the beginning of this lesson were talking about being asked those difficult level 4 sorts of questions. And that's what this focuses on next, all right? So in 5.6, here we've got a, I don't know if it's necessarily a level 4, but it's certainly not obvious. They want us to calculate the coordinates of t. Can you see, look at this, it's out of 6 marks. Okay, so this is something that's going to require a little bit of rigor in order to be able to get to the answer. So if we go back and we have a look, all right, the coordinates of t. So what does the point t represent for us? What is t? What happens at t? Absolutely, it's where the tangent does what? Amal, the tangent does what to the circle? Absolutely, Mangali. So it is a point of contact or a point of intersection, right? So we can say that that's it, it's a point of contact. Good. At T, the circle and TP touch one another. We could also say that at T, the circle and the radius, MT, touch one another as well. Does that make sense to everybody? So T is a point of intersection of 3 things: the tangent, the radius, and the equation of the circle. Does that make sense to everybody? Oh, good. All right. So now again, so intercausal at T, there are 3 things touching one another: the radius, the tangent, and the circle. So at T, we have the radius, the tangent, and the circle all touching each other at T. We already have the equation of the radius. We've just worked it out. We know that it is the equation y equals 2x minus 20. So we've got this. We've also got the equation of the circle. Remember, they told us in the beginning that the equation of the circle, it was x minus 8 plus, squared plus y plus 4 squared equals 45, if I remember correctly. I think I've written it down right. Yes, there we go. So we've got the equation of the circle. So we know that at T, these 2 that I've just written down over here are equal to one another. Okay, so this is where they expect us to do a simultaneous solution. Okay, because they want the coordinates at T, it means we need an X and we need a Y. So we have to do a simultaneous solution to get 2 different letters, X and Y. All right, so we're going to do a simultaneous solution. I'm going to just clear a little bit of space down here. Just move this out of the way. All right, okay, so I'm just going to write this down. Okay, so at T, we have the circle, which was x minus 8 squared plus y plus 4 squared equals 45. And just double check myself because it would be a pain in the bum if we walked the whole way through it and it was wrong. Okay, and we have got the radius, y equals 2x minus 20. So we need to do a simultaneous solution. Okay, so that we can get the x and the y at t. Okay, yeah, so the equation of the circle was given to you. So again, intercausal, try and use as much information as they have given you, all right? So if you don't have to go and work something out unnecessarily, it's going to save you time. Okay, so that's why you are constantly, with each time, you go back and look at the information that's given to you again and say to yourself, is there something else that I've missed? Is there something else that I've missed? What do I have? What do I have? Okay, so every time you finish a question, go back and read the information again and say, what information have I got that I can use that can help me? Okay, what's already part of my story? Okay, so that's part of our story. It was given to us in the beginning, and we've worked out the equation of the radius. Okay, so all we needed to do was realize that T is an intersection, okay, of the radius and the circle. Okay, it also happens to be the tangent as well, but we don't know anything about the tangent. I mean, we could, if we wanted to, we could go and work out the equation of the tangent, but why bother doing that when we have enough information to answer the question as is? Okay, they're not going to give us marks for working out things that we don't need to. All right, so now we're going to do our simultaneous solution. So what we're going to have to do is we're going to have to take the equation of the radius and we're going to have to sub it into the circle. So I'm going to write down the equation of the circle, x minus 8 squared plus, and now this y over here that I've underlined in green, I'm replacing it with 2x minus 20. Okay, because that's y, plus 4 squared is equal to 45. Okay, so I'm going to get a mark here for subbing in. Now, what I want to do is I want to collect together my like terms and then I want to square my binomial. Okay, so let me do that next. All right, so here I've got x minus 8 squared plus here I've got 2x and negative 20 plus 4 gives me negative 16 squared is equal to 45. Now let's multiply out our brackets. Okay, so x minus 8 squared means multiplied by itself. And we have to do the same thing with 2x minus 16. We need to multiply it by itself. And I'm going to bring the 45 over to the other side and make it equal to 0 because, of course, I want to get things into standard form. So now foiling out my brackets, I'm going to end up with x squared minus 16x plus 64. I took a little bit of a shortcut there. And with the next one, I'm going to end up with 4x squared minus 32x minus 32x will be minus 64x. I'm also taking a bit of a shortcut. And then 16 times 16 is 256. It's just, so that would be plus 256 minus 45 equals 0. So again, I just want to check in, is everybody okay? Are we all good? All right, because we unfortunately don't have much time left. Okay, Ibrahim, we are doing a simultaneous solution. Okay, so we have subbed the equation of our radius into the equation of our circle, and now we're busy solving for x. So we are going to end up with 5x squared. So that's when we add our x squared terms together. And then we've got minus 16x minus 64x. So minus 16x minus 64x gives us minus 80x. So that's our x terms gone. And now we've got 64 plus 256 minus 45. That leaves us with 276. Equals 0. And now what I'm going to do, just to make life easier for us, is let's use the quadratic formula. Okay, so x equals negative b plus or minus b squared minus 4ac, and I've got to show that I've subbed into the quadratic formula all over 2a. And I should get 2 solutions for x. Oh, I'm so glad intercausal. That's great. We're nearly there, guys. We've just got to work out what x is, and then we can work out what y is. All right, so let's get x. Okay, Oratila, you got 11. Nelisba, what did you get?
I got like completely different answers. I got 2 solutions for x, 13 and 3.
What did you get for x?
I got 13 and 3.
13 and 3. Yeah, that's what I'm getting as well.
Yeah.
Okay, so what we would do is we would look at the picture and we'd say, okay, well, at t, it has to be 13. Okay, because it's further to the right-hand side. So x equals 13 or x equals 3. Okay, so it would have to be 13. So now when we want to work out what y is equal, it would have to be 2 times 13 minus 20. So 6. Okay, 13 and 6.